Natalie Tavenci and her team have been searching for signs of microplastics. A special dye is mixed into the water, then carefully filtered. The aim is to catch any foreign particles like plastic. From there, a microscope and some CSI-type equipment try to pinpoint the particles.
You should be able to see some particles by eye.
Oh, yeah, I see one right in there. Yeah, and there's another one there.
And finally, using liquid nitrogen and a plastic detection machine, they analyze the particles.
That little tip there is going to be right on top of our particle.
It's going to touch the particle.
Yes.
And then it can tell you what it is?
Exactly.
A waveform is created, which is then matched to known plastics. The verdict?
The graph of this particle shows us these three peaks, which are very characteristic of polyethylene terephthalate, which is the material of the plastic bottle.
PET.
PET.
We asked you to look to see if there are plastics or particles in this water. What'd you find?
So what we were able to show is that of the 50 bottles that we tested, 30 of them were able to identify that there was plastic.
The majority of them.
The top chart shows particles above 100 microns.
How big is that?
100 microns is about the size, the width of a human hair.
So it's pretty small.
But big enough to identify many of the particles.
We know that there are different types of plastics. So for example, we found rayon, which is a material